Good morning, everyone. Today, we are going to see a problem on economic load dispatch. So in that, the ratings of the machine already mentioned the problem like 150 megawatts, 220 megawatts and 220 megawatts are the ratings of the three generating units that is mentioned in the problem located in the thermal power station. Their respective incremental costs are given by this following equation, that is DC1 divided by DP1 is equal to 0.11 P1 plus 12 in rupees. Here DC2 divided by DP2 is equal to, there is second fuel cost function, that is differentiation, that is equal to 0.095 P2 plus 14 in rupees. Next, DC3 divided by DP3 is equal to 0.1 P3 plus 30 in rupees, where P1, P2 and P3 are loads in the megawatt. So units also mentioned are the loads in the megawatt. Determine the economical load allocation between the three units when the total load on the station is, first one is 350 megawatt and the second one is 500 megawatt. So the demand, two demands they have given. First demand is 350 megawatt and second demand is 500 megawatt. So like this problem, if it comes, means what we need to do is first we are doing the here problem itself given, that is DC1 divided by DP1, that is given. So DC1 divided by DP1 is equal to 0.11 P1 plus 12, that is nothing but lambda. So how it is lambda means DCI divided by DPI is equal to lambda. So DC1 divided by DP1 is equal to lambda, or otherwise DC2 divided by DP2 is equal to lambda, or DC3 divided by DP3 is equal to lambda. So here, so that and the ratings of the machines also given, that is first machine is 150 megawatt and the second machine is 220 megawatt and third machine is 220 megawatt, that also given in the problem. So here what we did is we are equating that into to lambda. So DC 1 divided by DP 1, that is equal to lambda, or otherwise DCI divided by DPI is equal to lambda. So that formulation we are. Next, what is first demand we are taking, that is 350 megawatt we are taking. Summation I is equal to 1 to n. Here n is nothing but 3 generating units. So DCI divided by DPI is equal to lambda. So here DCI divided by DPI is equal to lambda. Here PD is 350 megawatt, that also given in the problem. So PD is nothing but P1 plus P2 plus P3, that is equal to 350 megawatt. So we are taking this as equation number 4. From equation number 1, we are taking P1 outside. So P1, if we take outside, P1 is equal to lambda minus 12 divided by 0.11. That we are taking as equation number 5. Next, from equation number 2, P2 we are taking. So P2 is equal to lambda minus 14 divided by 0.095. That we are taking as equation number 6. Next, P3 is equal to lambda minus 13 divided by 0.1. That equation we are taking as 7. Now, what we are doing is we are substituting this P1, P2, P3, that is equation number 5, 6 and 7 in equation number 4. That is demand. P1 plus P2 plus P3 is equal to 350. We are just substituting this equation. That is this equation we are substituting and equating it to 350. Simplifying this and we are finding out the lambda. Take your scientific calculator and calculate it. Okay, calculate by your scientific calculator. Take lambda outside and you can easily find out the lambda like this. So by finding lambda is equal to 21.6859, 24.6859 is the value of the lambda. So you are also got same answer or not, you just make a comment. Next step, here substitute lambda in equation number 5 and 6 and 7. So we'll get P1, P2 and P3, where P1 is equal to this already from the equation 5, Just you need to substitute lambda is equal to that whatever we calculated, that is 24.8658. As I said before, after decimal, don't round off, take four digits. After decimal, take 4 digits. The same like that we have taken here. We are substituting and finding out the P1. So when substituting the value of lambda and finding out the P1, we are getting the P1 as 116.96 megawatt. Similarly, P2 is equal to same lambda we are substituting in equation number 6. And similarly, we are getting P2 as 114.37 megawatt. Similarly, P3 also lambda value we are substituting here. And we are getting the answer P3 as P3 is equal to 118.659 megawatt. So here, now we need to check because whether it satisfies the load demand or not, that we need to check. So while checking generating units P1, P2 and P3 satisfies the load demand 350 megawatt. Approximately it's equal to 350 megawatt. So it is satisfying the load demand 350 megawatt. Case number 2. Case number 2 here given in the problem is we're taking the load on the station as 500 megawatt. Now the load we have to take as 500 megawatt. So here we are taking PD as 500 megawatt. So P1 plus P2 plus P3 is equal to 500 megawatt. Same equation 5 and 6, 7. We need to substitute in equation number 8. So this we are taking as equation number 8. Similarly, we have to substitute P1, P2 and P3 in this equation number 8. Just to substitute these values from 5, 6 and 7. Just substitute here and further simplification, we'll get the lambda value as 29.9305. You also may tell in comment whether you are getting the same answer or not. Now we are substituting the lambda in equation 5 and 6 and 7 and finding out the what is the value of P1, P2 and P3. So P1 is equal to lambda you are substituting as 29.9305. So when substituting the lambda here in the P1 equation, we'll get the P1 value as 163 megawatt. Similarly, P2 lambda we are substituting over here and we are getting the answer as P2 as 167.68 megawatt. Similarly, P3 we while substituting the value of lambda here in the P3 equation, we are getting the P3 value as 169.305 megawatt. Now we need to check whether it is satisfying the demand on. So P1, P2 plus P3 approximately that is equal to 499.985. That is approximately equal to 500 megawatts. So generating units P1, P2, P3 satisfies the load demand 500 megawatt, and also it is within the rating of the generating units given in the problem data. Already mentioned that rating of the generating units also. That also you need to check. Because here they mentioned the rating of the generating units within P1 should be 150 megawatt, P2 should be within 220 megawatt, and P3 should be within 220 megawatt. So after finding out the answer, you need to check whether it is within this generating limits. That is a rating of the generating unit. So first case also you need to check. Yeah, it is in the rating of the first generating unit because 150 megawatt. So here we got 116.96 megawatt. So here P2 we got I think 250 megawatt is the limit. So here also we got within that limit. So P2 also satisfies. P3 also same 250 megawatt is the limit. So here also what is the limit here? Yeah. So 220 megawatt. So 220 megawatt, it is within the limit. So here also P3 also satisfying that limit, generating limit. Next case number 2. Here also you need to check whether it is in the limit. So here P1 also within the limit. P2 also within the 220 megawatt, that is also in the limit, and P3 here also it is within the limit 220 megawatt. It is a limit. So you need to write the conclusion like it is all P1, P2, P3 are within the rating of the generating units that is given in the problem, and also it satisfies the demand. So like that, you need to conclude the problem. Sometimes the thing is that here in this problem, demand is given as two times demand is given. So demand is given as 350 megawatt and as well as the 500 megawatt like that. So like that, you need to conclude the problem.